Hey everybody, so in this video we're going to talk about section 5.2, which has to do with graphs of functions. Okay, so this is section 5.2 and we're going to talk all about graphs. So this is when you'll find that the stuff we talked about in A.4 about reading graphs is going to be really helpful. So the first thing we want to do is talk about, in the previous section we talked about how to recognize a function. Now we want to talk about how to recognize the graph of a function. Okay, so Okay, so a graph is the graph of a function if it intersects all vertical lines at most once, right? So if you are thinking about vertical lines, that vertical line could cross the graph one time or not at all, but it shouldn't cross the graph more than once, okay? Now the name for this is the vertical line test. Okay. So that's how you decide if the graph that you're looking at is a graph of a function or just a graph of a relation. Okay, now let's look at an example of using this test to decide. Okay, so we're going to look at some different graphs and try to decide using the vertical line test whether or not something is a graph of a function. Okay, so I've drawn some graphs and we're going to decide together. Okay, so remember what we're going to do is we're going to take a vertical line either in your mind or you can use a ruler or something, and you're going to move it across the graph and see if it crosses the graph more than once. Okay, so for this first one, we're going to move across, okay, and we're going to see that if we were to draw a vertical line like this, for example, you can see that it's crossing the graph just at this one point here. Okay, so we're going to imagine that all the way across the graph from left to right. Okay, and we can see that there's no vertical line that would cross the graph more than once. Okay, so does this represent a function? Yes. Okay, and it's because it passes the vertical line test. Okay, now we're going to look at part B, very similar shape, just turned on its side, and we're going to think about a vertical line moving across this graph. Okay, like this. Now we want to see if there's any vertical line that would cross that graph more than once. So let's draw an example like we did here. Okay, you can see that this vertical line, for example, would cross here and here. Okay, so we would say that this fails the vertical line test. So this is not a function. Okay, now how does this fit in with our idea of functions from last time? Well, if you think about these 2 points, because they're lined up like this, they're going to have the same value for x. In this example, it looks like both of these points have the x value -1. But because they're not together, they're going to have two different values for y. For example, this has y equals 1, this has y equals -1. So we're kind of seeing the same thing as last time, where we're having these 2 points that the input value is the same and the output value is two different things, right? We know that that means there's no function, and that's exactly what the vertical line test checks for. Okay, so let's look at two other examples. So right now for yourself, go ahead and think, does this part C, this circle, and this part D, this kind of corner shape, does that pass the vertical line test? Okay, hopefully you've decided for yourself. For me, this circle definitely does not pass the vertical line test. You can see this one intersects twice, so I would say no. Okay, but here, any vertical line that you draw is really only going to get one part, so I would say yes, this passes the vertical line test and it is a function. Okay, all right, let's look at our last set of examples. Now these two examples are meant to be exactly the same, except this has a closed circle here and this has an open circle. Okay, now the closed circle means this point is part of the graph. Okay, this open circle means this is not really part of the graph. This graph goes right up to this point, but it doesn't actually include that point in the graph. It's a hole, it's an empty point on the graph. Okay, so let's see how that affects these two. If we look at this graph, you can see the dotted line. These are lined up vertically. It already shows you where this function or where this relation fails the vertical line test. Okay, you can see these 2 points are both on the same vertical line. So no, this is not a function. Okay, there's the vertical line that it fails this vertical line test. Now over here, because this isn't really part of the graph, you can see that they don't really overlap here. Okay, so this one would be yes. This one is a function. Okay, all the other vertical lines, right, are only going to cross one of those two pieces, but here we can see because these ones aren't lined up the way that these ones are, that makes this one a function while this one isn't. Okay, I know you guys probably haven't seen a lot of graphs that have holes in them like that, so I hope you understand what that means. If you don't, please feel free to check in with me at 1:30. Okay. All right. So I don't think I need that. All right. So let's look at an example of another graph. Okay. And we're going to see what types of questions we can ask. Okay. So here's a graph here. You can see it has the same attribute, these little holes that we talked about in the previous example. Okay. So remember, these are not really parts of the graph. So we don't have the problem of this failing the vertical line test, right? It passes the vertical line test. This is a function. Okay. So we're going to ask first these 3 questions. Okay. I'm going to make it so we can see the whole graph over here and then our questions. So we're going to find P of 0. Okay. So here's where our skills from 8.4 really come in. We're going to read the value of this off of the graph. Okay, so what's important to remember from the function notation is this 0 is an x value, and it is asking you for a y value. Okay, so we're going to go to where the x value is 0, okay, on the graph, which is here. And we can see that the corresponding y value for this point is -2. Okay, so that's what we're going to give as our answer. Remember, the format is the same as in 5.1. It's asking you for P of 0. So you say P of 0 equals, and then you give your corresponding y value. Okay? This is an x value. You're giving the y value. Okay? So with that information in mind, go ahead and pause the video now and have for yourself find P of -3 and P of 2. Okay? Using the same method. Okay. All right. So for us, let's find p of -3. Okay, so we're going to go to -3, which is going to be here. Okay, and then we're going to give our corresponding y value, which you can see is 1. So we're going to give p of -3 is 1. Okay, so for these 3 questions, A, B, and C, they're giving you x values and asking for y values. We're just doing that in function notation. Okay, so same here. They're giving the x value 2. Okay, so that's here. Okay, and then we're going to give our corresponding y value, which is 1. Okay, all right. I actually want to do one more example like this, and we're going to do it together. So we're going to find p of 1. Okay, sorry, I bumped my camera. All right, so if we want to find p of 1, we're going to go to 1. Okay, and here's why I want to talk about this example in particular. So you can see that there's the empty dot here at 1 and the closed dot here at 1. So you need to decide which one of these really represents the graph. Okay, so remember, the empty dot means this is really not part of the graph. So when we're looking at this, this is really the point that we're talking about for p of 1. Okay, and because of that, I'm going to give my value p of 1, my corresponding y value from this point here, which is -2. Okay. All right. I hope that makes sense. I know that can be a little bit confusing when you're getting used to these graphs with the holes in them, but you guys will get used to them. And remember, the hole just means it's really not part of the graph. Okay. So let's move on to part D. Okay. Find all values of x so that p of x is equal to 1. Okay. Let me get my camera to focus here. There we go. Okay, so we're looking here. They're giving us, remember, this is the output. So they're giving us a y value of 1. So we're going to look for y values of 1. Okay, well, that's going to be this part here and this part here. Okay, so we're going to give those corresponding x values. So for this part, we would say they're between -4. So we would say between -4 and -2. Okay, and then for this part, we would say between 1 and 3. Okay, so this is for this part over here between -4 and -2, and this is for this part over here between 1 and 3. Okay, so again, for this example, they're giving us the y value 1, and we're finding corresponding x values. Okay, so let's do that again. Okay, so they're this time find all the values of x so that p of x is -2. Okay, so they're giving us the y value -2. So when we look at our graph, that's going to be this part. Okay, and then we're going to list all of the x values that go with that. So that's going to start at -2. So between -2 and, right, so they go right up to this point, which is 1. Okay. All right, and the last part here, find all values of x so that p of x is greater than 1. Okay, so we're looking for where the y values are larger than 1. Okay, so that's going to be this little part. I'm trying to think of different ways to indicate which part we're talking about. Okay, and this little part. Okay, so we're going to give the corresponding x values that go with these two parts. So for this part here, we would say that this is 1, 2, 3, 4, 5. We would say it's between -5 and -4. Okay. And Okay, so then when we look at this one, this is 1, 2, 3, between 3 and 4. Okay, so again, you guys don't have to list this in any particular way. You're just stating the range in words, right? So you're just saying between this number and this one, and then between this number and this one. Okay, all right. I know, like I said, I am aware that you guys haven't spent a lot of time looking at graphs that look like these, so that's why we want to be comfortable with that. Okay, let's look at another graph. It might look a little bit more like what you're used to seeing. Okay, so here's our graph. Okay, it has this nice lump shape. Okay, and again, we can see that this passes the vertical line test and it is the graph of a function. Okay, so let's answer a couple of questions about this. We're going to find f of 0. Okay, so remember this 0 is an x value and we are asked to find the y value. Okay, so we're going to say f of 0 equals, and then we're going to give our corresponding y value. So here's the point where x is 0. Okay, our corresponding y value is also 0, right? Because this is on the point 0, 0, the origin. Okay, all right. Now, if you are following along, go ahead and pause. You guys are going to find f of 5 and f of 7. Okay, I'll pull this down so you can see it. Okay, I assume that we've found f of 5 and f of 7, so let's look at f of 5. That's this point here. Okay, and we're going to give our corresponding y value, which is 5, 6, 7. Okay, so remember the format of our answer. If it says find f of 5, we're going to write f of 5 equals. Okay, remember 5 is the x value, and we're giving our corresponding y value, which we saw was 7. Okay, and we're going to do the same thing for 7. So here's 7. Here's that point on the graph where x is equal to 7. So we're going to give our corresponding y value. So we would say f of 7 is equal to, and then we're going to give our y value. Now, if you look at this, it's just a little bit above 5. So I might say, for example, 5.2. Okay, now we talked about this in 8.4 and I'll repeat it here. If it's not exactly on one of the lines, you are estimating the value from the graph. So if you said 5.3 or 5.1 instead of 5.2, that's totally fine. Okay, all right, let's look at part D. Find all values of x so that f of x is 0. Okay, so we're going to look at the y value, right? F of x are y values, so we're going to look at the y value 0. So that's going to be this point. Okay, and we're going to give our corresponding x value. Okay, so because it says find x, our answer is going to look like x equals. And then we're going to put our x value, which was 0. Okay, and we could have known that because it's essentially matching up with our answer from part A. Okay, so let's look at the next one. Find all values of x so that f of x is 5. So I would encourage you now to go ahead and pause the video and do that for yourself. Okay, so we are going to look at values where the y value is 5. Okay, so that's this point here. Okay, and it's also this point here. Okay, we're looking at y values, okay, and we're going to answer with the corresponding x values. Okay, so this has an x value of 1. Okay, and our other point, this one, again is between, okay, so it's between 7 and 8. Okay, so we're going to say this is maybe 7.5. Again, if it's between, you are estimating based on the graph. So to me, this point looks like 7.5. If to you it looks like 7.2, that's okay. All right, now let's look at our last part. It says find all of the values of x so that f of x is greater than 5. Okay, so we're going to look, okay, so we want our y value to be larger than 5. Okay, so think about what larger means in terms of up and down, right? So if you want something that's larger than 5, right, remember the points we marked are the points that are equal to 5. So if you want something bigger, that's going to be above, okay? So we're talking about this whole piece of the graph here. Okay, that's the part that's above 5, right? Meaning that the y value is greater than 5. Now we're going to give all the corresponding x values. So the x values start here and they continue all the way to this point. So they're starting here at 1. So we would say between 1 and, okay, and then they're going to go all the way out to this value, which we said was 7.5. Okay, so those values would be between 1 and 7.5. Okay, all right. So I hope that makes sense to you. We're mixing our skills that we got in 8.4 with reading graphs with the stuff that we learned in 5.1 about functions and function notation. Okay, let me know if you guys have any questions, and I'll see you soon.